Hello and welcome to our next lecture. So today we are going to be doing chapter 13, 14, and 15. 13 kind of piggybacks on what we did on Tuesday, so it's a little bit more of that visualization and the plotting, and then 14 and 15 are going to go into text. So let's get started. Chapter 13 is called Map Mashup, and it's actually quite a short chapter. If you can't tell by the name, we're going to be putting maps underneath our data, and we're going to demonstrate that integration of data sources to aid in your decision making. We're going to utilize that ggplot for geographic map representation as opposed to just a regular graph. We're going to plot geographic and numerical data with one visualization, and we've got a whole bunch more of R functions to learn. So let's get started. Creating map visualizations with ggplot2. So again, we have something else to install. You know, it's sort of a mashup where we're going to bring all the data together. We need to import and install a ggmap and a getStatesMap. So we need to make sure that those are activated in our RStudio. What we're going to do is we're going to create a dummy data frame, and then we're going to use the geometric map to create a map. So here you can see we've got a simple map, and it's a ggplot dummy data frame. Okay, that's what we're using. Map simple. Okay, we've got white on black, longitude and latitude as far as our limits go, and we're saying it's a basic map of the continental USA. So if we were to run this code with like basically an empty data frame, let's see what would happen. Pretty cool, right? So you can actually get just a basic map of the continental United States, and here's your black outlines with white fill. Now, if that data frame actually had data in it, we can locate those points on this map. So that's actually what's kind of cool about it. So creating the map visualizations with the ggplot. So you can color code for state population. Okay, and let's take a look at this when we look at the July 11th population data from that census that we've kind of been pulling throughout the course. Okay, so ggplot, here's my data frame of my states. Okay, and the map ID equals the state. Okay, here we're going to say pop color. Here's your map. It's going to be a map of the US, and we want to fill it using the July 11th population here. Okay. Here, again, we're doing that layering that ggplot is actually famous for. So, you know, we can take these in baby steps. So you could actually do one line of code and see what and, you know, display your plot and see what happens and see how these change. Here's your next one. Your limits are going to be your US latitude and US longitude and your US latitude. And then here we're going to title it state population. So if we display that, what happens now is that fill is going to be based on that July 11th population. So you can see there's a legend here on the right hand side. It's a black and white gradient that we have going on here. And you can easily kind of visually see this, you know, where the populations were low and where they were high. I think this is a pretty nifty tool that you really don't have to do too much into to get a lot out of. Okay, so we've shown how to do a visualization by filling in states, but how do we show a point on a map? Okay, so a logical location to put points is an address. Okay, as you know, that's better than a specific longitude or latitude. You may not know what that is. So geocode, which is shown here, is going to return that latitude and longitude points for a location. It uses Google, and the result is going to be stored. Okay, so here, hard code latitude and longitude. If you know the latitude and longitude, you can add a point here and then put your latitude and longitude. Most of us don't know that. Otherwise, what we can do is we can use that geocode and we can send it. So if I send it a city, it's going to go to Google and get a latitude and longitude out of Google, and that's what it's going to use. Then it's going to use X and Y to draw points on the map. Now, the map is going to use latitude and longitude as its X and Y axes. If you want to add a second point, okay, second point is a little bit more difficult. Okay, so what you can do here, we've got a data frame location And we're going to put Colorado in it. Then let's go ahead and put Denver. So we want to get the geocode location of Denver. And then that's how we're going to indicate where it is. See, when you do this geocode, it's actually going to show you where it's getting that information from, which is kind of nice. Okay, so let's see. So after we do this, 2 points are going to be added to the map, the latitude and longitude, and it's going to be Denver, which is an approximation because, like, if say we say Winston-Salem, it's a large, region area. So Google's going to return like approximately where it is. Most of the time it's like the center of the city or the center of the area. So a visualization on a map is much more advanced. So what questions can we answer with the map? Okay, so here is an open data set of US companies, and this is the file that the example goes through in the book. So let's take a look at this specific example when we put it on a map. So here we've got lots of data points going on in our map, okay? So what we want to do is make sure that a city isn't blank, because if a city has no name, it's not going to be reflected on the map, okay? We want to clean up some state abbreviations. Say you've got 2 different abbreviations for the same state. You want to make sure that if it says Nevada, it's not NEV or as opposed to NV, because that would be, we want to make sure we're in the same place. We want to create a city and state column in our data frame. That's the easiest way to go through this. And then you can do that geolocation using those columns. Okay. Then you're going to show your locations on a map. And of course, we're probably going to have errors on this. Hopefully we're not getting through too much data, so we're able to easily catch those errors. So another example that we can do is there is a color package that we can put in there where you can create a variable specifically for color coding the companies by size. Here I called it My Colors, and I used the Our Color Brewer library. So if you do want to use that library, make sure that it is installed and the little check mark is next to it is on to be able to use it. Now, again, we did discuss this a little bit, but keep in mind if you have an audience that might possibly be colorblind, so you can go from light to dark, and that still will give you a gradient enough where colorblind people can see. So what I'm doing here is I've got 3 colors and I'm indicating different shades of gray. So what is this going to do? This is going to create that shading. And again, I've got shading going on with my points, and it is, it's available to see in black and white, so you can print in black and white, but you could also use color as well. That's really all there is to the map visualization. I did put a link to another video that I found on YouTube that has a lot of great detail when it comes to using map visualizations in particular. So next, let's go on to chapter 14, and what this is going to be is this is going to be looking at text and unstructured data and kind of look at text data mining. So what we're going to do is we're going to access and analyze unstructured data. We're going to explain the purpose of word clouds. I just used a word cloud in a presentation the other day, and it was actually quite well received. Apply the text mining and word cloud packages to do basic text mining. And we've got some more functions that we're going to learn. So yes, right? First, let's look at a word cloud. I love word clouds. I don't know why. I think they're great. Okay. It's a visual graphic of word use. Okay. You're looking at unstructured data, speeches, Twitter, text. What I use it for is I took a survey of items from faculty that they would like to see implemented into workshops. I took all of the words that they gave me as far as the survey goes, and I made a word cloud of it. What it did is it really makes the words that are basically have the highest count be the largest in the word cloud, and then the words get smaller as the word count goes down on those words. So looking at this, you can just very quickly see that some of the big ideas are big data, analytics, storage, technologies, okay? And then it starts to get smaller, right? Complex databases, internet. And you can see it even goes down to really small words, which means that it's all, only there one or two times, like the words also, set, tens, grow. So it's a really cool way to present text data. And from it, you can visually see how many times that word was used in whatever it is that you're reading. In order to look at text data, you're going to have to read in the text file. So if you do a new project in RStudio, you can read in unstructured data. You can use a scan like there is here, send it the file name. And here, what this is doing is it's saying start at the beginning, and the separator of the text is going to be a new line. Okay, so what that's going to do is each time it hits a new line, it's going to put it as a new item in your list. So if you look at this, it's in words 1, it's putting the first basically paragraph, okay, because it goes till there's a new line. Then it starts the second part of the list, and then it goes until it finds a new line. Okay, so that's how it's going to go through this when I tell it to use a /n. A /n is a new line. You can use things called a read line. Okay, a read line is going to read exactly what it sounds like, line by line. There's less parameters to use, and it is going to store each line as a character string. So that's helpful when we need to actually manipulate that data. When you use read lines versus scan, the output is a little bit cleaner, okay? So here you can see here's my first one, but there is kind of a blank in there because there was a blank line in the actual text output file. The first way, the scan, totally disregarded it, okay? And you also have it set like words sub 1, words of 2, words of 3, and this just it's a little bit cleaner to read for the human eye. Another way to read text is that you can read in HTML directly. You can then parse that HTML, and then you can convert it to text, okay? There is something called an HTML tree parse. So here I've got my URL location. Here I'm using an unlist, okay, to do it. Unlist the results is going to create the vector. So this is where the vector is created. Here's my HTML tree parse. So in this doc.html, that's where it's saving the actual text, and then here it's converting that text into a vector. Okay, you can see it kind of does the same thing, except here, remember we had that new lines, and it's keeping in those characters that the other ones actually stripped out for us. Now there is a text mining package. Okay, now text mining is the practice of extracting that useful analytic information from some kind of text. It's more statistically focused than natural language processing. Text mining is going to break down your corpus, which is going to be your grouping, into word sequences, and then it's going to tally up the contents. Okay, so in this case, we're treating text as if we were counting objects. Okay, but those objects just happen to be words. So there is a TM package. Okay, so again, if you make sure it's installed and activated if and when you want to use it. So here there's a vector source. You can create a corpus out of it. Here's all you can do. If you display it, it'll show metadata. You can map. You can make everything lowercase, remove punctuation, remove numbers, remove words that are not in English. Okay, so the TM package really gives a lot of information and a lot of different ways for you to actually use that data. I'm going to try and find another video that just goes into the TM mining package. So hopefully I'll have one linked for you in the assignments. Using that text mining package is a class. And then corpus is in that package where you can use a words.corpus, and you have to understand what your stop words are. Okay. A term document matrix, it's basically a rectangular data structure with terms as the rows and documents as the columns, okay? It extracts the terms as defined, statistically or by a dictionary, either individual words or compound phrases, and then it'll report the statistics on that. Okay, there is a function that you can use called inspect to inspect the term document matrix and see what it actually contains. If you do just output, it's going to give you the output, kind of what you have: maximum term length, of term frequency, what it was weighted on, non and sparse entries. Okay, so it's going to give you that overview, kind of like the summary of what is in there. But you can use that inspect and send it in order to see what's in it. Now, creating word clouds. Now that we've got our data in some kind of vector, there is another library called Word Cloud. So again, make sure it's installed and checked in RStudio if you're using it that way, or you can use the install and library functions if you're using R, but I think everyone's using RStudio. You prep the data as a plain data matrix, okay? You sort it by frequency, and then you call the word cloud. So here's word cloud. Names, you're going to want word counts. The minimum frequency is 2. So what I'm saying here is anytime there's a word that only appears once, ignore it. Okay, I need it to appear at least twice. The maximum number of words I want is 50, so it's going to take the top 50. So say there's 1,000 words, it's only going to take the top 50. Okay, and we've got a color indicator here. This is a rotation, so you can see, if you know how sometimes the words, we'll see it in the picture, they'll go like 90 degrees and stuff like that. So here's a word cloud. Okay, see, we've got the rotation here, and a lot of times the rotation will just make sure it doesn't turn completely upside down, not gonna lie. But here we can see, again, it's the top 50 words that are used. And the higher the frequency the word is used, the larger the word appears. So here we've got women and we've got history. Next we've got citizens, states, oligarchy. Okay, it's kind of showing in the Constitution, these are the important words. So this actually does a very good transition into chapter 15. So what we're going to look at a little bit more is, we're still going to talk about that unstructured data. Okay, we're going to jump in by looking at sentiment analysis. We're going to look at that sentiment analysis text mining technique. Okay, and then we're going to look at other methods of text mining. And we've got, of course, some new functions. So sentiment analysis uses a lexicon of positive and negative words to assess whether the overall tone of your corpus is positive or negative. Okay, so is a review of a movie positive review or negative review? What about a speech? Okay, is your speech a positive speech or a negative speech? It's going to tally the number of quote positive words versus the number of quote negative words. Okay, and it's going to give you a score. So here we have got basically a data file that we're going to use. Okay, when we output it, the file contains a list of positive opinion words. The file and papers can be downloaded. Okay, it's got some information about it. Let's go into looking at it. So let's remove all of that sort of metadata at the top, which was those, the title and all that stuff. We just want the words, right? So let's remove, all of the instructions. Okay, if I do a head, then I can see A plus, abound, abounds, abundance, abundant. I'm fine. Here are my positive words. Okay, so P is for positive, N is for negative. Okay, we downloaded 2 files, one with positive words, one with negative words. Okay, so here's my negative: two-faced, two faces, abnormal, abolished. These are kind of funny to me. I don't know why. I think they are. Now, what we can do is we can calculate the total number of words that we have. Okay, and we can create a vector that just has all the words. Okay, so now let's go into that sentiment analysis and use the match function. Okay, so we're going to match the words with how many positive words we have. Okay, So it's going to return a vector of the position of the first matches. Okay, so anytime a word matches something in the positive word list, it's going to it's going to add 1. Okay, a running match of positive words, here we go, where it matched is not equal to 0. If it's 0, it means it didn't match. So the length of how many times it matched, 12. Okay, so there were 12 positive words in that text. Okay, so there were 12 unique words. 12 unique words in there. Now, M words, names, M count, number of positive, there were 17 positive words with 12 of them being unique. Okay, so this is going to give you the unique, this is going to give you the total. So 13, 14, 15, 5 of them were repeated. I did math today. Yay. Okay, now you can do this same set of code to find the negative words in this group text. Okay, so here I did the exact same thing. Matched, no matched. Remember, 0 means it did not match. Anything more than that means it matched. The number of negative words, there were 13 negative words. How many were unique? Okay, there were 11 unique negative words. So they only repeated 2 negative words instead of the 5 positive. Okay, so from this, you can see that the speech was made up of 9% positive and 7% negative. So would you call it positive? Would you call it negative? Because here's my ratio. Okay, and your ratio is your number of positive to your total, right? So that's where you're getting your ratio. So again, to convert it to a percentage, 8.9% and 6.8%. To me, it seems like it's a pretty neutral text that we had read, right? Only 9% of it was positive, 7% was negative. It kind of balances itself out. Now, if you were to use this and it comes out saying 95% positive, I would call that a positive, sentiment. So that's what sentiment analysis is. It's looking at whether it's a positive or a negative. Now, other uses of text mining, you can use it to parse many different sources of text to search for specific words or trends in words, specifically tweets. Okay, if you're working in social media, what is the top trend of the day? Okay, if you're on Twitter, it does do trends. This is the text mining type of thing that it's doing to find out what those trending words are. Things such as call centers. Maybe they want to find where most of their issues lie. They will use a text mining on the call information to find out where their customers are having the biggest issues. And finally, news feeds. To see what the news of the day is or something along that nature, you can do a text mining to see what is the most popular news that is out there in the world. Now, this pretty much wraps up the lesson for today. There are some assignments going forward. And again, I'm going to try and find something on YouTube that does a really good job of going into that text mining for you to watch. So as always, I'm available for questions and email answers whenever I can, and happy coding.